Good morning everyone, my name is Bipin Kulkarni and I welcome you to the second video of the CISSP series. In this video, we are going to discuss the CISSP exam and its questions. The topics included in this video is what is the exam all about. We are going to have an overview of the exam. We are going to discuss the 8 domains in CISSP. We are going to discuss what are the topics within those domains, and then we are going to look at a few sample questions of what kind of questions would be asked in the exam, what should be the thought process in answering them, and what kind of knowledge is required for us to understand and answer those questions. So let's get started. What is CISSP? CISSP stands for the Certified Information Security or rather Certified Information System Security Professional. It is considered as a gold standard in the field of information security. It is a management certification. So when you're in the senior management, this is the kind of certifications that you would require for your management skills. Now, this is a non-technical or a semi-technical certification. Here, it's nothing about vulnerability assessment or penetration testing. You're not going to do anything hands-on. You are not expected to know hacking, or you're not expected to know how to configure firewalls, antiviruses, and whatnot. It's basically something that over a period of years of experience, you have evolved a certain understanding of how security policies should be constructed, how they should be implemented, and how security affects an organization. So here you are responsible to create an overall security policy for an organization to help maintain the security posture of an organization. Now, as far as the certification is concerned, it has a validity of 3 years, after which you don't have to give the exam again. However, during these 3 years, you have to earn a certain point. So it is known as a continuing education points that ISC² allows you to generate points by attending lectures or by attending webinars, by publishing white papers, by providing trainings. Obviously, all of these should be authorized and you should have a validation from an authorized party that you have done this activity. Once it is verified, you will be awarded certain points. Once you have collected sufficient number of points, you will retain your certification beyond the 3 years. The passing rate of this exam is less than 50%. So it's not how much you require to score. What this basically tells you is the amount of people who actually clear the exam in the first attempt. Now let's not get disheartened because of this. Essentially, the exam is quite tough. It's known as a mile wide and inch deep exam. That means you need to know just about everything and anything that is there to be known in information security. And that's something that we are going to discuss when we go into the 8 domains of CISSP. What happens is there are a lot of people who are not actually prepared for the exam, who think they are prepared, attempt the exam and sadly fail in their first attempts. Some people just misjudge the exam and not prepared for it. So the fact that I'm trying to put across is be very well prepared. I've seen people who study for months together, attempt a lot of questions, ensure that their knowledge is up to the mark, and only then do they attempt the exam. Anybody can register for the exam, to be honest, and clear the exam as well. However, to get certified, there are 2 different avenues. So if you have experience of at least 5 years in 2 of the domains that are in the CISSP course, you get certified. So even if you clear the exam, there is a validation process that happens after the exam where you have to submit documentation to prove to ISC² that you have that level of experience. And once it is proven and validated, you get certified as a CISSP. If you do not have that 5 years of experience, you get certified as an associate of ISC² for CISSP, and they give you 6 years during which you can achieve the level of experience, prove it to them, and then get certified as a CISSP. So you can see the stringent levels that are taken for this certification. The validation is basically documentation and proof that you have to submit and which is verified. So even after you clear an exam, to get validated and get certified, it can take up to 5 to 6 weeks for ISC² to validate and provide you with the certification. With that, let's go and see the exam. Let's have an overview of what the exam is all about. The governing body is ISC², that's what we have been referring to. And the professional experience, at least 4 years of college degree or additional credentials from ISC²'s approved list that will satisfy 1 year of required experience, and 5 years of paid full-time work experience in 2 or more domains. Like I said, anybody can give the exam, register for it, attempt it. Once you clear, then that's where the criteria of your work experience comes into the picture. You prove 5 years of experience, probably by a letter from your organization, from your HR saying you have this kind of experience that is relevant to the certification. They will ISC square will validate it, you get the certification. If you don't have that experience, you get associate of ISC square, and then you get 6 years to attain that level of experience, after which you can get certified. The exam fees, $699, so it's an expensive exam. A single attempt for each voucher. So if you fail, that's another $700 for the second attempt. The fact being, if you fail for the first time, you cannot attempt the exam for the next 30 days. If you fail for the second time, you cannot attempt the exam again for the next 60 days. And if you fail for the third time, you cannot attempt the exam for another 90 days. So there's a cooling off period after each attempt. So I would suggest study hard, go for the first attempt, clear it, and nail it. The maintenance fees for your certification is again $85 for 3 years. The exam length is 3 hours, and the questions could vary from 100 to 150. 150 being the max questions that can be asked in that exam. You can clear the exam well before 150 questions, so be prepared for that as well. But imagine when you're walking into that exam, bear in mind that you will be asked 150 questions and you have to time those in 3 hours. 180 minutes, that's what 3 hours is. So if you do the math, not much time for every question. So it's just a minute and a half or less than that for each question. And the questions could be very descriptive, could be confusing. So you have to have your mental faculties really strong during the exam. The passing score is 700 out of a possible 1000 points. Exam language is English. Testing centers, there are ISC square authorized centers where you need to book that exam. There's a huge process that you have to follow too, where you go for the exam itself. So once you have registered on the ISC Square portal and you purchase the voucher, they will give you a list of centers in your vicinity that you can look into. They'll give you a calendar to give you the possible dates that you can attempt the exam on. Select the center, select the date. Reach the center at least half an hour before the scheduled time. There is a verification, so you have to carry your identification, a government issued document, either a passport, driver's license, where you have to prove that you are who you say you are. And once the verification is done, only then do you get to attempt the exam. The question formats are 3 types: multiple choice, drag and drop, and hotspots. Multiple choice is the format that we are going to look at when we look at sample questions. It's the same. They give you a question, they give you 4 options. Either one or more options need to be chosen. They will specify if there is more than one answer to that particular question. In a drag and drop, it's more like match the following. So there will be a column A and column B, and they'll ask you a question and say, okay, column A gives you the options, drag and drop whichever correct answer is from column A to column B, and then submit the answer. If the answer is correct, you get awarded the points, else there is no negative marking. The third is a hotspot. A hotspot question is basically a diagram, let's say an architectural diagram that will be presented to you, and they will ask you to pinpoint a certain aspect within that diagram. For example, they may give you an architectural overview of a network, of how it has been established, and they will ask you for a network-based firewall, which is the most likeliest area that you want the firewall to be placed in. So you don't need to know how to configure the firewall, but from an architectural perspective, you need to know where that firewall needs to be placed for it to be the most effective for the given scenario in the question. These are the domains that are asked. So you can see it basically covers anything and everything that is there in information security. It starts off with security and risk management, which weighs 15% in your questions, in your exam. So if your exam is 115 questions, 15% would be around 22 odd questions. And risk management being one of the most important topics for these kind of certifications. Then asset security, which covers 10% of your questions, so that's around 15 questions. Security architecture and engineering, this is where your infrastructural knowledge, your security architecture, your enterprise architecture, all those come into the picture. There are a lot of theoretical models that you need to study in domain 3. And that covers 13% of your exam. Communications and network security, this is the most technical topic within all these 8 topics. This is where you talk about networks, you talk about TCP/IP, you discuss protocols like TCP, UDP, you discuss different attacks, man-in-the-middle attacks, DOS attacks, and this basically has 14% of weightage. Then you have identity and access management, which basically talks about users, subjects, objects, subject being the user, object being the resource, and a relationship between these to be created where people are authorized for some activity, authenticated, and only then allowed and also held accountable for whatever activity they have done. Then you go into security assessment and testing, so vulnerability assessments, penetration test, software testing, SASS, TAST a little bit. All those will be covered in domain number 6, which has 12% weightage. Then security operations, so security operations center or the SOC, day-to-day management of incidents. So your incident management would come into the picture, problem management, change management, all of those things would come under domain 7 as security operations, which has 13% of weightage. And then finally, software development security. Now, you don't need to know development or you don't need to know any programming. There are no program-based questions. They're not going to ask you how to code. They're going to ask you how to manage a software development lifecycle or a secure software development lifecycle. So this is where your waterfall models, modified waterfall models, spiral, agile, DevOps, DevSecOps all come into the picture. And this has 10% of weightage. Now it is near about impossible for everyone or anyone to get experience across all these domains. So you will have your strong points and you will have your weak points. The task is to identify where you're good at, understand those things, make the maximum out of it, then identify your weak points and start developing on those. If you're able to look at it from a theoretical perspective, however, if you can get an internship or if you can get you can say just an insight of how it works in the practical world, it would be very helpful. Now, that being said, as far as CISSP exam is concerned, it involves a very ideal world. The real world actually doesn't come into the question because the real world will have a lot of business logic to it. By business logic, what do we mean? Every organization will modify their projects based on the expertise that they have, based on the talent that they have, and based on the people or the hierarchy of the organization that has been established. So it can be customized to each and every organization. Since an exam cannot deal with these kind of customizations, we deal with an ideal world. So for the CISSP exam, we assume that we have all the resources, we have all the people that are required, we have an hierarchy in the training which is given out where we have rules for each and every person and job titles for each and every person, right? So when we go through the training, it is very essential that we understand what these job roles are, what their responsibilities are, so that when we get those questions, we can identify which person is going to attempt what. In the real world, things are very different. We piggyback, we take on multiple responsibilities, and that is something that CISSP doesn't adhere to. So you have to be very careful. Identify the job roles, identify the responsibilities, have that map, the hierarchical map created very well, and then try to implement the ideal world scenario from the CISSP standards to see what is going to happen. That being said, let's move on. Let's discuss the domains. Now, these domains we've already seen. What we can do is we are going to move on to the sample questions for each and every domain. Once we reach the domain, we'll see what the topics in that domain are. We'll look at the sample questions. Then we will go to the next domain, see the topics in that domain, and then look at the sample questions as well. So, what to study and those sample questions revolving them. So, looking at the first module or first domain, security and risk management. Now, this is one of the largest domains that could be debatable for me. I would say the largest domain could be domain number 3, security architecture and engineering. Could also be domain number 4 because it is quite technical, communications and network security. And could also be security operations because that's incident management, change management, problem management all together. But each domain is very important from the exam's perspective. If you're thinking about keeping a domain for options, forget it. That's not the right way to address the exam. Let's start off with the first one, security and risk management. This domain teaches you all about information systems management, and this talks about risks and everything. So what we are going to do is we are just going to go to the official document from ISC Square where these domains and their topics are given. So that's the exam outline from ISC Square towards CISSP. This is the latest document that is there available online. You can see the URL in my browser address bar, and these are the 8 domains. This is the exam, 3 hours, number of questions 100 to 150, multiple choice and advanced innovative questions. That's where the drag and drop and the hotspot comes into the picture. Though based on experience, I can tell you that 90% of your questions will be multiple choice. 10% would either be drag and drop and hotspots. Passing grade is 700 out of 1000 points. Exam language availability is English. Those who want to attempt in other languages, it is available, but then the exam is 6 hours and the questions are 250. So that's your option depending on which language you're most comfortable with. We are going to go with English. That's the language options coming in CISSP linear exam. 6 hours, 250 questions. Everything else remains the same. These are the languages supported: French, German, Brazilian, Portuguese, Spanish, Japanese, simplified Chinese, and Korean. The weightage, I guess, remains the same. And that's the first domain, security and risk management. So what does it pertain to? Understand and apply concepts of CIA, confidentiality, integrity, and availability. In the first video, we have gone through all the 8 domains at quite some length. We have discussed what CIA is all about and how the interrelationship is. So if you want a deep dive, or rather a deeper dive than what we are doing for the domains, go back to the first video, look into that, and then you can come back to this video again. So evaluate and apply security governance principles. So we have to understand what governance is. Now, governance is basically having a overlying architectural security policy that can be integrated with an enterprise architecture, and thus having your security policy in alignment with the business goals and objectives. Security should never become a hindrance for a business. Security should always become a supporting feature which should allow the business to be executed in a secure manner. So as a security expert, our first goal is to identify what the business does, what the business processes are, what is the business trying to achieve, and then we try to create a security policy revolving these to enhance the business functionality in a overall picture. So you're looking at organizational processes, acquisitions, divestitures. Acquisition is when, let's say, scenarios where you are trying to create a security governance policy. Now the business is trying to change because they're trying to acquire another organization and merge it within this organization. And now your security policy should encompass not only your organization, but the newly acquired organization. Let's say in the next 5 years, a business decides that the newly acquired organization is no longer profitable and they want to sell it off. And now that's where the divestiture comes into the picture. You are now trying to separate the entity that you have just integrated in your security policy, and you're now trying to separate it with confidentiality, integrity, and availability of the company's data intact without affecting the organization at any point in time. Understand the fact that security is not only about hacking or getting hacked. It's about being secure at all points in time during business continuity and business, let's say, business as usual kind of activities. So that's where your security control frameworks would come in. You're going to talk about ISO 27001. You're going to talk about COBIT, PCI DSS, NIST 800 series, and so on and so forth. And the most 2 important statements or terms in the CISSP is due care and due diligence. Due care is you doing your own research to identify what security controls need to be implemented or what kind of governance needs to be implemented. And due diligence is you yourself spending that much time, money, effort into implementing those decisions that you have come across during the due care, thus enhancing the security functions of an organization. So when we talk about business requirements, for a business to be effective, at the same time, it needs to be legal, it needs to be compliant to regulations and laws and to the contracts that have been created by the organization. So as far as the concept goes, when we say that security needs to be in alignment with the business requirements, the business requirements imply that the business is legal, is compliant to regulations, is compliant to their contractual obligations, and is following standards that have been prescribed to them. So all of them come together, and that's where your security mapping comes into the picture. You're looking at legal and regulatory issues like cyber crimes and data breaches, licensing and intellectual property requirements, and so on and so forth. And it will also include ISSP's Code of Professional Ethics. Now, this is a document apart from the 8 domains that we have talked about. Thus, what does this document talk about? This is the prescription from ISSP of professional ethics for a cybersecurity professional. Expect around 4 to 5 questions from professional ethics as well. So not only is this a document that you need to read and adhere to, you will be questioned upon this in your exam, and these are easy points to score. Professional ethics, something that is ethical, something that is not against the law. So it's kind of quite easy, but the questions can be confusing, so you need to go through the entire document really well. And then your organization will have its own code of ethics. However, if you look at the hierarchy, ISSP's ethics comes first. So your organizational ethics should not be contradictory to ISC Square's ethics in the first place. Then develop, document, and implement security policies, standards, procedures, and guidelines. Identify, analyze, and prioritize business continuity requirements. So here, that's where your risk assessment comes into the picture. If you're looking at a particular risk, that means a particular vulnerability has been identified. You want to see the likelihood of that vulnerability being exploited, and then the business impact analysis that it may have, based on which you would then create a plan to mitigate that particular risk by having a business continuity or a disaster recovery plan coming into the picture. Now, this is, as far as this domain is concerned, you're calculating the risk. It doesn't actually tell you how to mitigate that risk. That's when you go into the next future domains and discuss those technicalities. So you can see contribute and enforce personal security policies. Now, the thing about CISSP is physical security also comes into the picture. Why? Because if hardware is not well protected, there would be physical attacks, social engineering attacks that could be created, which would lead to data leakage as well. And the first and the foremost, most valuable asset of an organization is always human personnel. So CISSP would also deal with people protection in the first place. For example, protecting people against social engineering attacks, making them aware about these attacks. If there are natural calamities, you have to plan for them during your disaster recovery and business continuity plan, and ensure that people are safeguarded. Not only that, you have to tie these things up with identity and access management. For example, account creation, account management, onboarding of employees, offboarding, termination of employees, third-party contractors, consultants that you're going to hire which are not employees but third parties coming in to your organization, providing intelligence, and so on and so forth. So all of those come into the picture as well. And then that's where your risk management concepts come in. It gives you a very good overview of how to identify those risks and so on and so forth. Now, this is what the first domain is all about. It itself is very huge. And as we go ahead, we can tie this domain to the rest of the domains. For more deeper analysis, go to the first video and then we can come back to this. So let's start with the questions. The first question, now these are very short one-liner questions. Your exams would be more descriptive. To be very honest with you, if you go online, no matter what practice questions that you try or whatever dumps, if you can find those, you will find none of them will be ever any close to the actual exam questions. You will find a lot of sites online that sell you CISSP dumps with 100% guarantee for you to clear. Don't fall for that. It's just a money-making scam. Those questions will be similar questions, something that will give you an insight of what the exam is going to be. But when you attempt the exam, you will find out that those questions are way different from the actual exam itself. Coming back to the questions, the primary goal of security awareness program is, now what is a security awareness program and why is it created? The primary goal. So is it to provide a platform for disclosing exposure and risk analysis, to make everyone aware of potential risk and exposure, to provide accurate risk and exposure results, a way of communicating security procedures? Now the answer to this is to make everyone aware of potential risk and exposure. Doesn't mean that you're trying to make everybody an ethical hacker. What you're trying to do is, in your organization, you are trying to create a security awareness program which allows your employees to know what kind of policies exist in your company, what rules need to be followed, what are the procedures that need to be followed for them to safeguard themselves and company assets as well, and ensure that data leakage and data loss are kept at a minimum. So you're basically trying to make everyone aware of the risks that they may have. For example, social engineering, not clicking on links, not going to unwanted sites, and so on and so forth. Question 2, a contingency plan should address which of the following? Potential risks, residual risks, or identified risks. Now, what is a potential risk? A potential risk is something that you may foresee in the future, something that may exist. A residual risk, we'll come to that. What is an identified risk? A risk that has been identified, is known to the organization, and the organization is aware of it. So potential is something that may come into the future. Identified is something that exists right now. A residual risk, on the other hand, is a risk that was identified earlier on, mitigated, but after mitigation, there is still an amount of residual risk that exists. So these terminologies need to be understood really well. Let me give you an example of a residual risk. So let's say there's a SQL injection flaw that has been identified in an application, and that's now an identified risk. Now you've got two options in front of you: go through a software development lifecycle again, recode that part of the application to mitigate the risk, or else have a security control like a firewall, a web application firewall watching that risk. Now the ideal scenario would be that you go through the development process again, but that is going to take time. So you put in a compensatory control that is a web application firewall in the meanwhile to mitigate that risk, and then have the recoding done, and then later on resolve the risk altogether. So when we put in the firewall to mitigate the risk temporarily, is the risk actually addressed? No, there is still a possibility of a SQL injection attack happening, but we just have it mitigated to a certain extent because there is a firewall watching it. So that means that there is still a residual risk, a risk that is remaining even after me implementing the security protocol or the security control. That is what a residual risk is. Something that remains even after I put in a security control, which can be taken care of later on or can be accepted and just moved upon. So coming back to the question, a contingency plan should address which of the following? Either a potential risk, a residual risk, an identified risk, or all of the above. And the correct answer to that is a residual risk. What is a contingency plan? A contingency plan is I still have a security control, but something may go wrong. And for that, I want a secondary control to be in place to ensure if the first control fails, the second control would still be able to identify that and stop the security incident happening. So we are looking at residual risks and then having a contingency plan to manage those residual risks. Question 3. When the cost of the countermeasures outweigh the cost of the risk, the best way to handle the risk is to reject the risk, transfer the risk, accept the risk, or reduce the risk. Now, there are 4 ways a risk can be managed, right? Accept the risk, avoid the risk, transfer the risk, or mitigate the risk, right? Rejecting the risk is not an option. But what is the question? Cost of a countermeasure outweighs the cost of the risk. So what is the cost of a risk? The cost of a risk is basically the impact that the organization is going to face in a monetary manner if the risk is realized. To mitigate that, we have a countermeasure in place. So if in the previous example, I have identified a SQL injection attack, and the countermeasure to that is me implementing a security control, a web application firewall to mitigate that risk. However, if somebody executes that risk, somebody does a SQL injection attack, the loss that I'm facing is only $100 per incident. And the maximum incidents that can happen in a year are 10. So 10 into 100 is $1,000 per annum is what that risk is going to cost me. For me to implement a web application firewall, on an annual level, it is going to cost me, let's say, $15,000 in licenses, management, salaries, and all of those things. Which means that I'm facing a loss of $1,000, but I'm spending $15,000 to prevent that loss. I'd rather have the $1,000 loss than spend $15,000, right? So, in this scenario, the cost of the countermeasure is outweighing the cost of the risk by $14,000. So, in this scenario, which is the best way I would do it? Either reject the risk, which is never an option because you cannot reject the risk. Transfer the risk. What is transferring a risk? Transferring it to a third party by purchasing insurance, example, right? So if I purchase insurance saying if this gets compromised, it's the insurance company who's going to make the payments. I'm safeguarded. Or accept the risk or reduce the risk. So in this scenario, accepting the risk is basically accepting the risk the way it is, moving on because there is nothing that you can do about the risk and you're willing to accept the risk rather than spend money on it. And reduce the risk is mitigating the risk by implementing the firewall and spending that money and then incurring those losses. So the best answer out of this is accepting the risk. Why can't I transfer the risk? Because there is no such insurance where I can, in the given example, where I can get that kind of an insurance policy. Reducing the risk would entail me spending that $15,000 to mitigate the $1,000 risk, thus incurring a $14,000 loss, which is against the business logic. A business needs to make money, not spend money. And that's the fourth option that's left, that's accepting the risk, which means we are not going to implement the firewall because it is outweighing the cost of the risk. We are just willing to accept the risk itself and move on. That's the first domain. Moving on to the second, which is asset security, consists of topics about physical requirements of information security. Let's go back to the document in hand. So moving on to domain 2, asset security, we talk about assets. Assets could be, now, okay, let's get into the definition of what an asset is. Asset could be anything that has a monetary value associated with it from the organization's perspective. It could be data, it could be virtual assets, it could be physical assets, it could be anything and everything. It could be a license, right? You purchase an operating system. The operating system comes with a virtual license that installs on your machine or is associated with an email address. even that license has a value, thus even that license will become an asset. So the basic definition is anything and everything that is owned by the organization and has a monetary value associated with it, right? Thus we talk about asset classification as well. Asset classification could be data. Within data itself, there would be sub-classifications like confidential data, non-confidential data, public data, and so on and so forth. Physical assets, virtual assets, networking assets, anything and everything that you can come across would be classified here. Determine and maintain information and asset ownership. So your asset management program comes into the picture. And when you say asset ownership, the organization owns the assets as they are. However, roles and responsibilities that you have created in the organization will ensure that some assets are virtually owned by somebody. That means that they are responsible for the well-being of that asset. So you have to identify who, for example, HR. Now, HR is a function, human resources, but they also need IT assets. For example, a payroll, which will institute a payroll software, a database, right? A web application server, if you will. And all of these assets are now owned by the HR department. So there are hundreds of people in HR. So who exactly owns this? That's where we identify the owner of that particular asset, saying you are responsible for the well-being of these assets. You belong to this department. So normally the head of that department would be the owner of those assets and would determine what kind of access controls, what kind of maintenance, management, security mechanisms are required. Then we talk about protection privacy. So data owners, data processors, remnants, collection limitations, determining, ensuring appropriate asset retention. So let's say data, right? Even if I have data, how long do I retain data? If you go into privacy acts of organizations or of countries rather, so GDPR for European Union, GDPR basically states that you will only retain personal identifiable information for as long as the organization requires it. The moment you have no reason to have that data with you, you're going to delete that data. So which means automatically says you're going to retain that data till it makes business sense. Once you figure out it is not required, you're going to delete it in a secure manner, which is not recoverable to unwanted parties. So you have to determine those asset retention periods. We have to understand what those retention periods are. So even if for your physical assets, there will be a life of the asset that is associated with it. And once the life of that asset is over, even if the asset is working properly, you have to discard that asset and you have to replace it. You have to do this with security in mind. Then the security controls for all of these things. Understanding data states. Data states could be in three different aspects: data in motion, data at rest, and data in use. How are you going to secure data during all these three stages? What are the protection methods that you're going to utilize? Then establishing information and asset handling requirements. So that's what domain 2 is all about. Let's look at the questions. So the first question in domain 2, which of the following is responsible for setting user clearances to computer-based information? Is it operators, data owners, security administrators, or data custodians? Understand the question. Who is responsible for setting your user clearances to computer-based information? And the correct answer to that is security administrators. They are responsible for setting the user clearances. Who are going to be responsible for allowing the user clearances? That's going to be data owners. What is generally concerned with personal security? Management controls, operational controls, technical controls, or human resource controls. Now, what is personal security? Personal security is people-centric security. You're looking at people and you're ensuring that their security comes into the picture. Technical controls can be used for data assets or physical assets like information technology, but technical controls may not be that relevant for a human. A firewall is not going to help any human any which ways. Management controls are administrative controls. That means a policy that will help you implement controls. But for personal security, it's the operational controls that are going to be associated with it. Which of the following factors determines the frequency of information security audits in any given environment? So the age-old question, for you to remain secure, how often do you want to conduct a security audit to verify your vulnerabilities, your penetration tests, to verify your security controls are working properly? So would it be dependent upon asset value, the risk-based approach, management discretion, or level of realized threats? And here the answer to that question is risk. The moment a risk is identified, for example, at what various stages would a security audit be triggered for an individual asset as well? And that can be tied down to incident management, change management, and problem management. So if there is an incident, a security incident with a database server where there has been an attack on that server, I probably want a security audit done on that server to identify vulnerabilities, flaws, and then to mitigate those risks. Similarly, if there is a change that has been going on into your organization, you first want to go into a risk assessment strategy, and then you want to look at security audits based on the risks that you have identified, right? So a security audit is not only periodic based on compliances or regulations, but it also can be integrated really well in your incident management, problem management, and change management scenarios. That's domain number 2. All right, let's talk about domain 3, security architecture and engineering. Now, this is where you tie up security architecture and enterprise architecture. If you look at the first domain, we have talked about risk assessments, we have talked about confidentiality, integrity, and availability, and then we have moved on to the second domain where we talked about asset security. So that's where we talked about data classification, asset classification. Now, it starts off with the enterprise level architecture. So something like TOGAF. What is enterprise level architecture? It's basically data center architect and a network architect trying to create data flows, deciding how communications are going to happen between various devices. They're going to try to do network segmentation for web application servers, database servers, look at network isolations, network access control lists, and may even decide how firewalls and where firewalls would be required. Once that architecture is created, we need to secure that architecture to ensure that whatever data communications are happening within that framework, they are secured in a manner where all the risks that the organization may be exposed to are either managed, mitigated, accepted, transferred, whichever the way it is, right? So here you start off with physical security, you start up with trusted platform modules. So looking at the outline, this is where it starts off with implement and manage engineering processes using secure design principles. So this domain will talk about using TOGAF and then using a Zachman framework to interact with all the data owners, all the asset owners, querying them about the security of the assets, the requirements, because it is not the security architect who determines how secure the device will be. It is the asset owner who determines the requirement of security. For example, continuing with the HR example that we were talking about earlier, if the HR department of head is responsible for the database, for the payroll application, it is that person who would be determining the security levels. So based on the security architecture, let's say a Zachman framework, we would create a questionnaire that needs to be filled out by the asset owner, the HR department of head, and would be supplied to us, the security heads, and then we would try to create a security profile based on their requirements. So if the HR department head comes back to me and says that they require to be adhering to a particular standard or they want X kind of security, it is us who will validate that requirement and it is us who will execute it and protect that asset based on their requirements. So this is where your security architecture meets enterprise architecture by using various frameworks. This domain will introduce you to not only Zachman framework, it will again take you to a trusted platform module. It will talk about ITSec, TCSec, common criteria, and so on and so forth. So this is again a very extensive module. Some people struggle with it because it is largely a theoretical module, and some people would struggle with the concept of what is a security architecture and an enterprise architecture. It is very important to understand the differences between them. For example, TOGAF is an enterprise architecture where a data center architect would deploy and streamline those devices on which a layer of security architecture such as ISO 27001 would be implemented to enhance the security and ensure that the infrastructure remains protected at all point in time. This module will also deal with managing vulnerabilities on assets, applications, web-based systems, mobile systems, and embedded devices. So this is where your engineering comes into the picture. By this module, we mean when we are deploying infrastructure, we need to engineer it with security in mind. We need to architect in such a way that security enhances the business needs, business requirements, and they are executed in a secure manner. Let's look at a few questions based on domain 3. Question 1. When a computer uses more than one CPU in parallel to execute instructions, it is known as multiprocessing, multitasking, multithreading, or parallel running. Now, here we need to understand what is the difference between multitasking, multithreading, multiprocessing, and parallel running. Now, it would be very difficult to explain all these processes in this video. So, here we are talking about executing instructions. That's multiprocessing. Multitasking is performing multiple tasks at the same time. Multithreading is where processes create their multiple threads to manage certain functions. Here, when we are parallelly executing instructions, it is known as multiprocessing. Question 2. who mediates all access relationships between subjects and objects of a system. Now, what is a subject, what is an object, and what are access relationships? So access relationships would be your permissions that you have created. Now, what are permissions? Permissions would be something that a person is authorized to do. So if you look at the CIA, which we discussed in the module 1, confidentiality, integrity, and availability, how do we keep data confidential? By only allowing authorized users access to that data. What are authorized users? Authorized users are people who have been identified and are allowed access to certain resources. How do we do that? By having an identity and access management platform in place, which will be discussed later in the next domain. But confidentiality would include IEEE standards. IEEE starts with identification, authentication, authorization, and accountability. Identification is identifying the person, who they are. Authentication is verifying that they are actually who they claim to be. Authorization is where the access relationships come into the picture, where once we have authenticated a user, we are creating a matrix which allows them access to certain resources to a certain extent. Some may have read-only access, some may have modify access, some may have delete access, etc. So in this scenario, we are talking about access relationships between subjects and objects of a system and who mediates that. Now, when you say reference kernel, information flow model, or security kernel, or firewall, in this particular scenario, for this particular question, based on the options that are available, we are talking about a rule-based access control system, which means that we have created rules of what is allowed into a network and what is not allowed within a network. This can be controlled by using a firewall. So this can be controlled by using a firewall. Question 3. Which of the following is not a spam blocking architecture? Now, what is spam and how you're going to block it? It can be at the client side, it can be on the email server where we have identified spam filters, could be application based. In this scenario, mail blocking service is basically you creating a blacklist which will block emails from certain addresses or from certain things. So this is not a spam blocking architecture. It's basically a blacklist where you're blocking emails. But spam blocking architecture could either be at the email server based, could be at the client side where they're using, let's say, Microsoft Outlook Express and they've created rules within it, or could be on an application where you have configured rules over there. Moving on to domain 4. Now, this is where the technicalities come into the picture: communication and network security. The network security domain covers topics focused on protecting the network of an organization. So communications, TCP channels, UDP channels, the TCP IP. So you come across the OSI layer, you map the OSI layer with the TCP IP layer, and see how a data fragment packet is created. Looking at domain 4, we are talking about the OSI layer, open systems interconnection, compared to the TCP IP or the transmission control protocol over internet protocol models. We're talking about internet protocol itself. We are talking about converged protocol, software defined networks, wireless networks. Then we are talking about securing network components. So we talk about firewalls, types of firewalls, endpoint security, network access control devices, and we look at them over virtualized networks, VoIP, multimedia, talking about remote access, data communications. Right, so all of this is concerned within domain 4. Now, OSI and TCP itself could take hours for people to understand, to people to comprehend how computers work. Now, these are theoretical models, and we need to create an understanding of how theory merges with the practical world. Let's look at a few questions. What is the purpose of using a VPN? Now, the essence over here is, what is a VPN or a virtual private network? How is it created? What technologies can be utilized within it? What encryption mechanisms can be utilized? And why are we creating that encryption mechanism in the first place? So is it to secure remote access into a network, securely connect two networks together, secure data tunnel within a network, or all of the above? So here with a VPN, we are basically trying to do everything. We are trying to create encrypted tunnel between two systems or two networks where data can be transmitted in a secure manner, where man-in-the-middle attacks or network-based attacks would be mitigated. A VPN can secure packets from data link layer onwards to the application layer. Question 2. Which of the following characteristics are not included in the TCP protocol? Now, what is a TCP protocol? TCP is a connection-oriented protocol. It is a reliable protocol that is utilized to communicate between servers in a reliable manner. So a TCP protocol being a connection-oriented protocol, which is reliable in nature. So which of the following characteristics are not included? Connection-less protocol, that is the UDP protocol. So this is not included in the TCP protocol. Question 3, which, if you remember the previous slide, would be the UDP protocol. A UDP protocol is a protocol that is used for its speed rather than reliability. When it is real-time processing that is required, we use UDP. So most of our VoIP communications would happen over UDP protocols. Okay, so looking at domain number 5. Domain 5 talks about identity and access management. So this ties up with your asset management, your risk management, because if we go back to the confidentiality, integrity, and availability aspect of it, identity and access management is basically allowing authorized users access to resources by authenticating them and also holding them accountable. So this becomes the essence of how you're going to allow people to access the resources that you have in your organization. Let's look at what this domain covers. It will talk about physical and logical access to assets. So servers need to be protected by putting them in a secure server room, thus restricting access to them and allowing access only to those few people who require access to them. Once we have secured those servers, this is where we talk about physical security, whereas we got a secure room, we are going to monitor that room, we will have access controls, we will have guards monitoring who is getting access or who's trying to get access to that environment. And then you're going to create logical access as well, where we, let's say, have swipe cards on the door locks. So anyone with logical swipe card can access that particular facility. You're also looking at managing identification and authentication of people, devices, and services. So here we are going to talk about authentication mechanisms, single authentication, multi-factor authentication. We are talking about single sign-ons. We will talk about federated identity management modules. We'll look at CASB, or cloud access service brokers. We will talk about session management from applications and so on and so forth. We will also talk about third-party identity as a service provider, where we integrate those identities like OpenID into our organization and we validate people based on the identity that they have created with those organizations. Then we talk about access control lists, which would be role-based access controls, mandatory access controls, discretionary access controls, attribute-based access controls, rule-based access controls. And then there are a lot of theoretical models that are integrated in this module, which talk about lattice-based approach, which will talk about other theoretical models which will help you align how identity and access management is implemented in an organization. So at this point in time, we will also be looking at a life cycle of how identities are managed. For example, onboarding of people, deboarding of people, termination of employees as they move within the organization by getting promotions, demotions, or changing departments and assuming a new role. So here we talk about how we can provision an identity, how we can deprovision an identity, how it is to be managed. We're going to create a relationship between the creator of this identity and the approver, who's going to be a manager. So even if somebody is allowed to create an identity, they will only create it if they have an approval from an appropriate manager. So let's look at questions from domain number 5. The first one, which of the following is the most important factor while selecting a biometric system for securing critical assets? Now here the domain talks about the types of authentication mechanisms. There are 5 types, essentially 3 basic types, which talk about something that you know, which is a password, something that you have, a swipe card, someone that you are, a biometric, somewhere that you are, location based, and something that you do, like CAPTCHA. So these are the 5 basic authentication types or mechanisms that you can utilize in an organization. Multi-factor authentication is having multiple of these options integrated in our identity and access management module to enhance the security. Now coming back to biometrics have positives and negatives amongst them. So with the biometric, there are 2 types that we talk about: false acceptance rate and false rejection rate. What is a false acceptance rate? Somebody, let's say you're using a thumbprint to authenticate people. Somebody put down their thumbprint. The person is not actually authorized. However, it was read incorrectly and the door got unlocked and the person got access to that particular area, which is a false acceptance rate. A false rejection rate is an authenticated or an authorized person actually trying their thumbprint, but it not getting recognized. Thus, they did not get access to the area or to the device that they wanted. Now, the question here is, which of the following is the most important factor while selecting a biometric system for securing critical assets? Now, would I want to focus on false rejection rate or false acceptance rate? Then we also have equal error rate and maximum allowable downtime. Maximum allowable downtime is if the biometric measure fails and if nobody is getting access to any of the resources to what level or to what extent would my business be able to tolerate such an outage? Here the correct answer is the false acceptance rate, because if an unauthorized person gets access to my devices, that's the worst case scenario. If the biometric system is down and nobody's getting access, that may still be acceptable rather than having an unauthorized person getting access to very sensitive data. False rejection rate is also detrimental to the organization. However, it is not as bad as having a false acceptance rate introduced in the organization. The second question, which are the two major factors to measure biometric performance? Again, the question from the previous one, FAR, false acceptance rate, and FRR, false rejection rate, or FSE and ERR, IER and FAR, FRR and GIC. They don't actually relate. So the correct answer here is FAR, false acceptance rate, and false rejection rate. So these are the two major factors. False rejection rate may still be a little bit acceptable, but a false acceptance rate is not tolerable at all. Next question. A commercial application for steganography that is used to identify documents or verify their authenticity is either a digital checksum, an MD5 hash, a digital signature, or a watermark. Now here the keywords matter. We are talking about steganography, so suddenly people start thinking about hiding data within data. And then if you just isolate the words identify documents or verify their authenticity, we basically directly go to a digital signature, because that's what we utilize for a non-repudiation. However, what the question refers to is an application for steganography. Steganography is hiding some element which would be visible only to known people. We can utilize steganography to benefit ourselves or our organization by using it to identify the authenticity of a document. So if I am going to print out a document, maybe a watermark on the document which is not visible to the naked eye, but when I want to validate the document, I would search for that particular watermark. And that is the correct answer for this particular question. So that's what domain 5 is all about. All right, let's look at domain number 6, which is security assessment and testing. Now, this domain is all about assessments, auditing strategies, and testing. So from this domain, what you're going to take away is talking about internal audits, external audits, third-party audits, and the security control testing, strategizing about how we implement a vulnerability management system, a program within the organization that is repeatable, consistent, and measurable, can be tied up with other management programs like patch management, incident management, and anything and everything that requires a vulnerability assessment, like even change management. If something is going to change in an organization, you can have a vulnerability assessment done before you want to even think about allowing it or disallowing that change. Similarly, with penetration testing to validate the vulnerabilities that you've identified, log reviews, having a SIEM tool that will help you analyze or create a pattern analysis of what's happening within the infrastructure, what's happening within the organization from a security perspective. Then you're talking about collecting security process data, account management. When we say account management, identity and access management life cycle. So onboarding of an employee, offboarding of an employee, the lateral movements of an employee in an organization when they're getting promoted or they are transferred in from one department to another, right? So all of these would come under security assessment and testing to see how those policies are functioning, to analyze the effectiveness of those policies, thus the requirement for conducting vulnerability assessment and penetration tests. So let's look at a few questions on this domain. And let's start off with the first one. Which of the following ways requires the involvement of an information security analyst? So out of these 4 options, a systems requirements definition, system design, program development, or program testing, during which phase would you involve a security analyst? Now for this, we first need to identify why we require a security analyst. What is the job requirement? What is the activity that is going to be conducted by a security analyst, right? So in this scenario, the correct answer is program testing. In the program development phase, we won't need an analyst. We would need a program manager and architects who can develop a particular program, who can give it some semblance of what needs to be achieved. In the system design, it would be again an architect who's going to develop that system. In the systems requirements definition, again, so in the systems requirements definition, it's a requirement gathering about what you need to adhere to, what is going to be the baseline that you're going to create. So from these 4 options, you need to identify where would you place a security analyst, right? In the exam, it's the most probable answer that you're looking for. It's not the most idealistic answer, right? So from these four options, security analyst would most likely be involved in the program testing phase rather than any other phase. The second question, which of the following techniques is generally not used for monitoring purposes? Now, when you say monitoring, what is monitoring? Monitoring is looking into logs, activities, anything and everything that has already happened. So you're reacting to something that has already happened. And which of these following techniques is not used for monitoring? So you're collecting logs, you're analyzing those logs, what would be not be utilized? A penetration test, intrusion detection, violation processing, or countermeasures testing, right? Now, when you're monitoring, you would monitor a penetration test to analyze if the test was successful or not. Intrusion detection, that's the first input that you look at for analysis. Violation processing, anything is violated, any processes, any policies, you analyze them and you monitor them, thus you come to know that this has happened. In countermeasures testing, there's basically a test of the effectiveness of the countermeasures that are already implemented. At that point in time, you may not be monitoring these. The software program that acts on behalf of a user in their absence to carry out operations is known as an agent, worm, applet, or a browser. So, a program that acts on behalf of a user in their absence to carry out operations is either an agent, an applet, or a worm, or a browser. A browser is nothing but software that allows you to surf the internet. A worm is a malicious application that would be more of a nuisance value than anything else. An applet is something that allows you interconnectivity. An agent is something that can be automated, used for automated tasks, and can run those tasks in the absence of a particular user. So if you look at these questions, understanding what each and every word means, understanding and highlighting the keywords in the question itself, and then analyzing the scenario that you are placed in, and then identifying the most appropriate answer for that particular question. That is how you want to approach a CISSP exam. Looking at the next domain number 7, and that's security operations. Let's look at what security operations has for us. Now, in security operations, you're looking at a SOC, a security operations center. So your regular vulnerability management, incident management, problem management, change management, placing controls, analyzing all that information. So probably having an SIEM tool, configuring the SIEM tool, collecting all those data. So identifying event sources. What are event sources? When I have an SIEM implemented, I am not going to expect the SIEM to automatically start collecting data all by itself. And then again, I don't expect the SIEM tool to understand what kind of data it needs to collect. So for me, in a security operations center, after I have installed an SIEM tool, I first need to configure it to identify which devices I want to monitor, from which devices I want to collect that information, and where do I want to store it. Once I have all that information in place, after that, I'm going to analyze that data to identify if anything has been incorrectly going on, or is there any security incident that has happened, and those would be raised as incidences, and that would be sent to the SOC team for analysis and then an incident response, right? Similarly, intrusion detection and prevention logs would be utilized to identify something that may have been missed by the IDS IPS itself. You're going to place controls for investigations, like administrative controls, which would be policies that you have made. Then you've got criminal laws. So if something bad has happened that can be described as a crime based on the law of that land, how you're going to deal with it. Civil laws, regulatory laws, and industry standards. Regulatory laws would be, for example, GDPR in the European Union, right? A civil law would be where there is no criminal activity that has happened, but let's say there's a breach of contract between two organizations and the civil lawsuit has been filed against an organization for a breach of service level agreements. Regulatory would be the GDPR Act, where you have to report to a regulatory body, and if there are any flaws, you could be fined. Industry standards, ISO 27001, PCI DSS, and so on and so forth. So when you're looking at these requirements for investigation, all of these would have prescribed how you're going to handle that investigation. If it is a criminal investigation, an organization by itself doesn't have the right to investigate. They have to go to a law enforcement agency, and there is a procedure to follow. In case of a civil lawsuit, there are lawyers who would deal with this kind of activity, send out notices to the other party, then go to a court of law to file a lawsuit over there. In GDPR, there are timelines on how you're going to report a breach or how you're going to report an incident and so on and so forth. So in the security operations, you're creating a security operations center in alignment with all of these 5 requirements. You're going to look at logging and monitoring activities, having that SIEM tool, which will identify those devices that you want to monitor, collect relevant information that is prescribed based on all those 5 investigation types that we just discussed. Then you're looking at when you're looking at identification of assets, you go back to your asset inventory, asset register, you look at all the assets that you have, and then you make your strategy and plan how you want to collect those logs, right? And then this module will deal about how do you want to handle identity and access management, privilege account management, service level agreements, and so on and so forth. So this basically is the day-to-day business activity of an organization from a security perspective. So you are there to identify incidents. As a CISSP, you won't be executing this, but you would be creating policies revolving all of these aspects. So this is what you need to consider. This is what you need to strategize upon. And this is what you want to advise the organization to what needs to be in place to be more effective from a security perspective. Let's look at the few questions from this domain. How does a subject get access to an object in a multi-level security policy? Now, first we need to understand what a multi-level security policy is. We need to understand what a subject is and what an object is. Let's look at the options first. The subject sensitivity label must dominate the object sensitivity label. The subject sensitivity label subordinates the object sensitivity label. The subject sensitivity label is subordinated by the object sensitivity label. And to repeat the sensitivity tags again and again, the subject sensitivity label is dominated by the object sensitivity label. Too much sensitivity in a single slide. However, you can see that this just confuses the person of what they're trying to read. Not only you missing what keywords are, so people normally focus on a keyword called multi-level security policy and start getting confused in that, while we do disregard what a subject and an object is. Right? So a subject and an object is a relationship that is created between identity and access management, subject being the user, object being the resource that needs to be accessed by that particular user. After which comes a multi-level security policy, which is basically the access control matrix that you have created between these multiple objects and multiple subjects. So, for example, in this domain, you would also talk about theoretical models for access management, including lattice-based approach, where the sensitivity labels come into the picture. You would talk about Clark-Wilson model, you will talk about Bell-LaPadula model, and a few other models, right? All of them theoretical in nature, which can then, based on other implementations, be implemented in a real-time scenario. So all that understanding comes into the picture, and then you need to identify how those sensitivity labels in a lattice-based approach could allow you to create those labels for your subjects and objects, and then the identity and access management tool would become the verification factor where it identifies the labels for the subject and the object, and they, based on those labels, they allow or disallow connectivity or allow connections to happen. Now here the correct answer is that the subject sensitivity label must dominate the object's sensitivity label. So the user should have a sensitivity label that allows them access to the object which has an equivalent sensitivity label. So understanding those models becomes very much important, not only from an exams perspective, but when you're creating a policy, you basically are going to use these terminologies and you're going to create a policy around this. Moving on, the second question, managers of which department are ideal for the development of information security policy for an organization? Business operation, information technology, purchase, or human resources? Now, managers of which department are ideal for development of information security policy for an organization? And when we say information security policy, we would obviously assume that is the IT department who's going to deal with it, and it's the information technology in this case. But that's incorrect. It is the business operation. Why? Because right from the first domain, so we would be taught in the training for CISSP that security needs to enhance the business functionality, not the other way around. So we are in the business, or we are in the function of conducting a business which would offer services, and those services that are being offered, the business activity that has been conducted, should be supplemented by security, so those business activities could be conducted in a secure manner. At no point in time is security going to be a deterrent to business. The only reason for anything to become a deterrent to business is the legality of it. If a business is illegal, it will not happen, or it should not happen. However, if the business activity is legal, then security should not stop that activity from happening. Security should be implemented in such a way that the business activity is strengthened. There is security embedded within it, secure by design, and then the business activity goes on. So even if you're a chief information security officer or a security manager and you go and talk with the board of directors or the steering committee, as the terms you will come across in this training, you will understand that it's these people who would define how the business is going to work, what kind of business activity you're going to do, and then you provide the example. And I'll give you an example here. Let's say I'm an online retailer and I want to sell goods online, which is legal. I'm selling all legal goods. Now I want security team to come in, and they would help me to secure the function of being an online e-tailer, if you will. My security team is not going to come and tell me of not to go into that business or stop some services because they may be insecure, right? The security team's requirement is that if I want to sell goods online, they need to now create an architecture of devices, of clouds, of whatever is required to make it secure. So thus, the managers of business operations will always be the ideal department for the development of information security policies. They decide what the business is going to happen, and then the security team just complements it by adding the security to it. For example, just going on with this, a website is launched with HTTP. The security team comes into the picture and says data in motion needs security, so we're going to convert it into HTTPS. And at no point in time are they going to say HTTP is vulnerable, so we are not going to do this. We'd rather become a wholesale shop or something like that. And I'm just giving an example. And rather than me just rambling on, let's move on to the next question. Question 3, installing malicious software on the system to allow future backdoor access leads to violation of what integrity? Does it violate the data integrity, system, user, or network? Now, malicious software on a system to allow future backdoor access. So what are we doing here? We are basically installing a software or an application on a particular system which allows a hacker a backdoor access to the system. So this would violate the integrity of the system itself, right? The data would be compromised, but the data would be compromised because the system got compromised. A user doesn't matter because a backdoor is a backdoor entry where you can get access without even logging in as a user. And a network is just a way of communication at this point in time, but the essence being that system got infected, and through that infection, you got access to whatever was on that particular system. Now, that's domain number 7. Domain number 8, which is the last domain in the CISSP exam, is software development security, SDLC or SSDLC, secure software development life cycle, right? That's what is discussed in this domain. Let's go back to the CISSP guide and see what this domain would consist of. So, software development security. Now you can see software development life cycles coming in. So they're going to talk about different life cycles like waterfall model. They're going to talk about agile. They're going to talk about modified waterfall. This module also will talk about DevSecOps, DevOps, and anything and everything that would be there with the software development life cycle. Now, when we say software development life cycle, the essence of a CISSP is to add another S to the SDLC. The SDLC stands for software development lifecycle. The CISSP adds one more S, the secure software development lifecycle. So, as with everything, secure by design, which means security needs to be integrated at every phase of the life cycle, and it should not be bolted on. For example, a waterfall model talks about how the software is going to be developed and how it is going to be published or released at the end of the life cycle. At no point in time does it talk about security. Thus, security architect at that point in time would come into the picture and decide what are the requirements of the software, what are the security vulnerabilities or the risks that they see. So threat modeling would happen, and all those things need to be introduced right from the inception. So if there are developers or if there is a business requirement for an application, let's go back to the previous example. I'm an e-tailer. So to become an e-tailer, not do I only need a website. I will need a web application for that functionality to be given out. So I need to develop that application. In a regular lifecycle model, I develop that application and then go into security where I do a VAPT on that application, find out that there are disastrous results, and then I go back and start coding again, which is not a good scenario. So I have hired a CISSP who will then come into the picture during the SDLC and at the inception itself, when businessmen are talking about how the business is going to happen. At that point in time, the CISSP will come in and start with a threat modeling exercise saying, you know what, let's talk about what are the risks this application is going to face. You're going to handle a lot of payment information because people need to pay for the products, right? So credit cards, you're going to be involved. There's a database, so SQL injection attacks. So these are the threats that we are looking at. And now a threat modeling exercise would be followed by a risk assessment. Then would be looked at by an impact analysis. And then based on that, you will prioritize those risks. You will then educate your developers to use secure coding practices. At the same time, security testing would be done to see how the application is being evolved. And then by the time that the software development lifecycle comes to an end, you would have a secure software which had security by design integrated since the inception rather than having bolted on. Now, this is the ideal scenario that you're looking for. The expense and the budgeting, that's where the balance of capital investments and time to market and all that comes into the picture. But for the training, we will always be in an ideal scenario. We'll always have enough time, enough resources, monetary and human. And the exam basically looks at a very ideal scenario in which you got just about everything. You just need to make the correct decision. At no point in time are you going to think that if I start doing a particular strategy, it is going to cost me a lot of money, so I don't want to do that. That's the real world scenario. In the real world, you look at the costs, you look at the timelines, deadlines, and then you take a informed decision of how much you want to invest in what. In the ideal world, for the CISSP exam or the CISSP exam, there are no limitations. You are looking at the most correct way of doing those things, and thus you identify those requirements, and that's how you answer the exam. So you're looking at the security software environments that you require, configuration management, auditing and logging of changes, security impact of acquired software. Now, in this scenario, we talked about developing a software. What if I purchase a third-party software and I introduce it into my organization? Now, this software, when integrated, how is it going to impact my current security controls, impact my current identity access management, my networking, my other applications, my communications? So that's something that you want to assess as well, right? So let's go for the questions. Question 1, in which of the following RAID level the drive array continues to operate even if any disk fails? Now, in the actual exam, they are not going to be very technical. It's a managerial exam, so they may not ask you these kind of questions, but the knowledge is still required. So you need to know that there is something called RAID, the different levels of RAID, because you might want to use that as a solution in a particular thing. How do you want to implement RAID and all of those? That's not the knowledge that we want. But in this scenario, RAID level 7 is the ideal answer. Question 2, which of the following steps can be utilized or can be used to protect an organization against the failure of a critical software firm? Now, basically, what does this talk about? This talks about disaster recovery, or this talks about business continuity. For example, there's a failure of some sort. When there is something that fails, what does it do? It interrupts the business. So the moment a business interruption happens, what should kick in? The business continuity plan. If the business continuity plan fails, then the disaster recovery plan kicks in. So if you look into it, as we go in, we might even come against terminologies like RTOs, RPOs, return time objective, and recovery point objective. And at that point in time, you want to look at how do we want to recover from a data loss. And thus, you will come across solutions. Now, of the 4 options, full backups, differential backups, and incremental backups. And the 4th one, software escrow agreement. What is the difference between these? A full backup is a complete backup of the entire data that you have taken. Now, it sounds easy, but in an organization, data could be terabytes, petabytes, and to do a complete backup might take days, weeks, or a lot of time, right? It's not just copying 1 megabyte from a hard disk to a USB drive and be done with the backup. So full backups may be possible, but not on a regular basis. So maybe you do a full backup every week, which means that at the end of the week, if the data loss happens, then you have lost the data for an entire week because the backup was last week. Thus, it's not a very good solution. And to complement that, we could use incremental backups and differential backups, right? So the training would include all of these definitions of what these backups are, what happens. And then the fourth option, software escrow agreement. What is that? Now, in a software development or a software lifecycle, if I've purchased a software from a third party, my biggest risk is not of me getting hacked or the software getting hacked. From a business continuity, the biggest risk is if the software provider goes bankrupt or is taken over by somebody else or stops supporting the software, then what? What am I to do? Because I may have invested millions of dollars, or reinvesting into a different product and migrating to a different product would be expensive, very costly, and may be very time consuming. So what do I do at that point in time? So there is an option for software escrow agreement. What does that mean? That the source code of that software is placed in an escrow, which means, let's say in a bank, where the bank will hold the source code in a secure manner, and the source code cannot be accessed or be modified either by the developing organization or the purchasing organization. So it just sits with the bank. If the developers go out of business or they stop supporting, at that point in time, the escrow can be opened and the purchaser, that's us in this case, can still get the source code. So now we can develop the software, or we can go into the source code, analyze, and save ourselves from a disaster, right? So these are the four options. Now here you're talking about a critical software firm that failed. You're not talking about data that failed. So the correct answer here is the software escrow agreement, right? Question number 3. Now here we come across the word development models. Which one of these is a meta model that incorporates several other software development models? Are we looking at waterfall, modified waterfall, spiral, or critical patch? Now, describing each and every model would take a long time. That's something that I'm going to leave for the training. But here the correct answer is a waterfall model. Now, there's a big difference between waterfall and modified waterfall as well, right? So that's something that we will leave for the training. For now, that's the end of the slide. So I thank you for your attention for this video. I'll see you in the next video. For any comments, please make a comment in the comment section of this video. And if there's anything, I'll get back to you. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.